Let's go ahead and go over the Chapter 6 study guide. Uh, number 1 says write your answers using positive exponents, except actually 1 through 4 would be like that. We see that -5 is the base. We got the power of 8 on top with the numerator, power of 4 on the bottom with the denominator. We move the smaller one to the bigger one. So we're going to be subtracting 4 from both sides, so we can get rid of this 4 down here. And now we see that we got 4 minus 4, that's going to leave us 0 on the bottom. 8 minus 4, that's going to leave us 4 up top. We know anything to the 0 power is 1. So now we have -5 to the 4th power over 1, which is going to just be -5 to the 4th power. All right, let's go ahead and check out number 2. Number 2 says we got 2 times a times, or 2ab, I should say, all to the 3rd power. This 3rd power is going to be applied to the 2, the a, and the b. All right, so when we do this, we can't get the power of 3 to a or b because we don't know what a or b is, but we do know that 2 is to the power of 3. 2 times 2 is 4. 4 times 2 is 8. So this is going to be 2 times 2 times 2 gives us 8, a to the 3rd power, b to the 3rd power. Okay? And that's all you can really do there. Let's go to problem 3. Problem 3 says evaluate the expression. If I evaluate this expression, I see that the bottom numerator or denominator is going to be applied to my root. So this is going to be the square root of 9 to the 5th power, right? It's kind of like splitting it up and saying this is going to be multiplied to 1/2 times 5 over 1. We're splitting up these particular numbers. So this is going to be equal to 5 over 1, right, times 1 over 2. And as you see, if we were to multiply these together, 5 times 1 is 5, 1 times 2 is 2, that's where they got 5 over 2. So the 1/2 here is getting brought to the power inside. Now we got a power to a power. 5 over 1 is just 5, so they brought that over here. And so now I got 1/2. Remember, whenever I have a numerator or a denominator, excuse me, of 2, I'm going to find the square root of the base. So that's going to be the square root of 9 to the 5th power. The square root of 9 is 3. So now we have 3 to the 5th power. 3 times itself 5 times is going to give us 243. Number 4 says find the cube root of -512. Well, I know it's going to be a negative number because this is a number multiplied to itself 3 times. So we need a negative number multiplied to itself 3 times to get a negative answer. Right? So we're going to take -8 multiplied to itself 3 times. We know 8 times 8 is 64. 64 times 8, well, we know that's going to end in 32, right? Because 64, I'm just going to show you how I'm doing this mental math. 64, right? And then when I multiply that to 8, I know the first answer is going to be 32, and boom, there's a 2 there, right? And of course, we get the 3 up here. We got 48, 49, 50, 51. So -8 is multiplied to itself 3 times. That means my answer is -8. Okay? And since I don't have an exponent up here, I can just leave it as -8. I do not have to put parentheses around it. All right, let's go to number 5. Number 5 says that I'm going to identify the asymptote and find the domain and range. When I'm graphing f of x, the -2 to the 4 to the x power, I have to remember the parent function is 4 to the x power, right? So since we have a negative sign here, we know there's going to be a reflection. And since we have a 2 here, we know that that's going to be, well, it's bigger than 1, so that's going to be a stretch. And since this number is bigger than 1, I know it's going to be a line from the x going outward. Since this is a negative sign, it's going to be going downward, okay? So we're going to make the table. We see that we have x is -2, right? -2 is going to put this at 1 over 4 to the 2nd power, which is 1 over 16. And then we take -2 times 1 over 16. That's going to give us -2 over 8, and both 2 and, I'm sorry, -2 over 16. And 2 and 16 are both divisible by 2, and that's what they get, how we got 1 over 8. We're going to take these numbers and we're going to go ahead and replace them with x and get the answers here. Then we're going to graph it. When I do that, I see that I got f of x. And again, like I said, my line starts here towards by the x and then moves away downward because of the reflection, right? And this is going to be a stretch, all right? Or a reflection and a stretch with a factor of 2. All right, so when they say for the domain is all real numbers because this goes infinitely this way, right? And then this one goes infinitely this way, just going to take longer, but it's going to keep on going to the right. The range is up and down. That's going to be all the numbers that are less than 0, right? Less than 0. So the x-axis is the asymptote, right, of both the graphs, because the other graph wouldn't have been negative, and it would have been 4, so it would have been coming up like this somewhere. And then, let's see, of f and g, from graph f, you can see that the domain is all real numbers, right? That's what I said, all real numbers. And then the range is y is less than 0. All right, let's go to number 6. I'm going to move this so it's out of the way. Determine whether the table represents an exponential growth function, an exponential decay function, or neither. Well, when I look at this, I see that these are increasing by 1, right? So I see, I'm just going to put that out there. These are all increasing by a factor. I shouldn't say a factor, I should just say increasing by 1. Somehow I lost my dot, there it is. I'm adding 1 each time, right? And now down here, I see that, well, I'm actually dividing by 4 each time, right? I'm dividing by 4. 64 divided by 4 is 16. 16 divided by 4 is 4. And 4 divided by 4 is 1. All right? So, I'm sorry, I should have put a 4 there. Go. Okay, so we know this is exponential decay because the number is going down, all right? And it's definitely exponential because we're dividing down here, right? Now we could also say we're multiplying by 1/4, all right? Either way you want to say it, dividing by 4 or multiplying by 1/4 shows this is exponential decay, all right? This decay because we have a power, or we're multiplying by 1/4, right? That means that the number in front will be 1/4. Well, this is exactly what I showed you a second ago. We're adding 1 to the top. We're multiplying by 1/4 on the bottom. As x increases by 1, y is being multiplied by 1/4. That's exactly what we said. So the table represents exponential decay function. That's exactly what I said. All right, let's go to number 7. Number 7 says, let's see here. Looks like I did a little boo-boo here, so I'm going to make a correction. Okay, I'm back. Sorry about that. I had to go ahead and make a little correction to my animation. Number 7 says a website has 300,000 members. The number Y of members increases by 8% each year. This tells me an increase, right? This is going to be a growth. And we've got 8%. We can't use percent, so we're going to move the decimal over 2 places. So write an exponential function that represents the website membership after 2 years. I would say initially we have 3,000. We're probably going to have to multiply that to, I'm going to say, let's see, right up in it, that represents the website membership. So we're probably 1 plus 0.08. I'm just going to check here. Look at that. This would have ended up being 1 plus 0.08, and then we add them together, it would be 1.08. And then to the t power, because we don't know how many years it is. Now it says how many members will there be after 9 years? We're going to replace that t with 9. We're going to multiply 1.08 times itself 9 times, or in your calculator, put 1.08 to the 9th power. Okay? And then that's going to give you 300,000 times 1.08 999,004,62,710. And now when we multiply these together, we get, wow, look at this, 599,701.3881313296384. Wow. So we're talking about membership increase. We can't have point people. Imagine we're going to round this up. Yeah, we're going to round it up to about 600,000 members, okay? All right, we're on number 8 now. It says you deposit $900, okay, in an investment account that earns 7.5% annual interest compounded monthly. Write a function M that represents the balance in dollars of the investment account after 2 years. What is the balance of the account after 2 years? Wow. Okay, so let's see. You deposit 900, that's going to be an investment in front. This earns 7.5. We're going to have to move the decimal back 2 places, which will make it 0.075. Annual interest compounded monthly. So we're going to have to divide that by 12, right? So write a function M that represents the balance in dollars of the investment account after 2 years. So that N will get multiplied to T afterwards. So we're going to have 900 times, I would think it's going to be 1 plus 0.075 over 12, and then close parentheses, all to the power of T, or excuse me, N, which is 12 again, right? 12 times T. So let's see how we did there. There we go. 900 times 1 plus 0.075 divided by 12 to the 12 times T power. Now it's asking what is the balance of the account after 2 years. We're going to replace this T with 2. 2 times 12 is going to give us 24. And so we're going to take 0.075 divided by 12, add it to 1. Whatever that answer is, we're going to multiply it to itself 24 times. That's going to give us, well, okay, first of all, we took the 0.075, divided it by 12, and added it to 1 and got 1.00625. Now we're multiplying 12 times 2, that'd be 24, okay? And we're going to take 1.00625 and multiply it to itself 24 times, and then multiply it to 900. This gives us $1,045.16. So you start with 900. It looks like you gained about, let's see, maybe $145.16. Not much. So let's move on. Number 9 is up. It says a bacterial population, Y, after X days can be represented by the exponential function whose graph is shown. Find the population after 6 days. Okay. So first of all, we know that we need the starting point, A, because our formula for this one, I believe, was A times B to the, I think it was the T power, right? So A is actually going to be the y-intercept, and that y-intercept is represented when X is 0, so my Y is going to be 100, right? So that'd be 100. We're multiplying that to the exponential growth. So I'm going to look at the Y value here, and I see that I would have had to multiply 100 times 2 to get 200. So that means my growth, exponential growth, was 2, and that's to the T power. But now they're saying it's going to be 6 years. So I can actually get rid of the T and turn it into a 6. I'm going to take 2, multiply it to itself 6 times. I think might be 32. Let's see. Well, this would be 4 times 4 times 4. That's 16 times 4. Actually, 64. And then we multiply it to 100. That's going to be 6,400. We got 100 times 2 times X. We're turning X to 6. That's going to give us 64. And this is going to be 64 with 2 zeros afterwards, 6,400. All right. Now let's go to 10. The value of a car is $36,500. It loses 13% of its value every year. Okay, so we're losing value. Write a function that represents the value Y in dollars of the car after T years. All right. So the value of the car, let's see, the value of the car is 36,500, and that's the initial value, right? And then it loses 13%. So in this case, we're going to be subtracting, this would be 36,500 times 1 minus 0.13, right? So, oh, this was the population after 6 days was 6,400. There we go. 36,500. And now we're taking what they did here, what they left out, I'm going to show you, is this should have been y equals, this would have been 36,500, just like they got here. It would have been times 1 minus 0.13. We move in that decimal 2 places to turn it into from a percent to a number, right? And then times t. And 1 minus 0.13 is 0.87, okay? That's the function. Now, estimate the car value after 5 years, we're turning that t into a 5, right? So when we turn that t to a 5, we're going to take 0.87, multiply it to itself 5 times. That's going to give you 0.4984209207. We're going to multiply that to 36,500. That's going to give me $18,192.36. All right. Well, that was it. Next one is just showing you the Chapter 6 review. If you don't have it, you can print it out. I'll just leave this here so it's out of the way. And you'll have all the questions that you can practice at home that we just reviewed. Have a great night, and I'll see you in class for the test.